In this FactPod, we will answer the question, what is the power of a small-scale biorefinery? A biorefinery is defined as the sustainable processing of biomass into a portfolio of marketable bio-based products and bioenergy. For biorefineries, there is a clear definition. However, for scale, there's not. Compared to the largest petrol refinery, the largest bio-based ethanol refinery in America is very small scale. There is a 28-fold difference in size. To define the scale of a biorefinery, we need to make a distinction between processing scale and production scale. Processing scale refers to the amount of raw material processed in a period. The scale of a biorefinery depends on the availability of a given raw material. Production scale is the amount of product obtained in a certain period. So, the scale of a biorefinery depends on the flow of a feedstock in and the flow of an obtained product out. With that out of the way, small-scale biorefineries cannot benefit from the economy of scale to make them feasible. But what advantages does a small-scale biorefinery have over their larger competitors? And can this balance be true? A small-scale biorefinery allows for fewer transportation movements, the reuse of invaluable compounds and minerals directly on site. Processing in a small-scale biorefinery can increase storage times, speed up innovation, while at the same time creating more value for the farmer. Let's illustrate these advantages with examples. A great example of limiting transportation is the integrated pod-based biorefinery system in America. It is a system where small-scale biorefineries pre-process corn stovers by producing biogas and removing water. This increases the bulk density of the feedstock. The residual solids are co-combusted in a coal-fired boiler instead of being burned on site. The residual solids can also be used as soil amendment, which achieves the lowest greenhouse gas emissions. The pre-processing makes transportation over larger distances possible and enables the possibility of very large-scale biorefinery as the processing scale increases. Note that this is an example from North America. The configuration of transport and logistic network in Europe is way different and even more different in Africa, for example. Let's look at another example. This is cassava. Almost 500 million people in Africa rely on this staple food, but 40% is wasted since it spoils quickly, mostly after 1 to 3 days. Datco Phil Africa is a manufacturer of cassava-based products. They extract fibers, starch flour and paste from the cassava with their mobile biorefinery. These products can be preserved far longer than normal cassava. The starch paste, for instance, has a shelf life of 1 year. Datco bridges the gap between the smallholder farmers and the food companies with their processing unit. In the process, water with nutrients in it and tear weight can be directly recycled on the land, so the small-scale biorefineries ensures that the soil quality of the farmer is maintained. I need to place a critical note here. Datco tries to reform the conventional cassava industry. However, Datco seems to have ignored the local knowledge on cassava cultivation. Moreover, the local community does not want to abandon their local cassava varieties, change spacing rules and buy and sell their cassava stems. Also, on the market, higher prices can be realized than Datco can offer. For the farmers, the dependency on food companies is exchanged for dependency on Datco. In this case, the farmer benefit advantage is a very complex and social problem. Small-scale factories can speed up innovations, while large centralized operations can have a limiting effect for innovation. The requirement for initial investment is relatively low. A great example is Grassa, developing a mobile green grass refinery. They started out with a small plant in 2011 without full process optimization. In 2019, they are testing their 4th generation biorefinery. The aim was to develop over time. Lessons are learned from each iteration. The 3rd generation biorefinery processing costs are 2 times higher, while the 4th generation is 10 times cheaper compared to the 1st generation. Also, the capacity increased while being 50% more energy efficient. Grassa learned each step about their products, increasing their product output line to 4 products, containing more value than the products in the previous generations. The business case of Grassa was hardly feasible up until the 3rd generation, but the feasibility of the project has increased with each iteration and each new generation. So to conclude, small-scale biorefineries have some differentiating advantages over large-scale biorefineries. However, some of these advantages are not easily expressed in money. There are some pioneering companies working on small-scale biorefineries, but the number of companies taking this approach is still very limited. The feasibility of a biorefinery process is not only fixated on the economy of scale. By combining the power of small with the power of large, we will transition to a bio-based, circular and more sustainable future. Thank you.